to a cloud. Okay, so the first thing you always want to do is figure out the vertex.
Mm-hmm.
And it's really simple. Set the expression inside the absolute value to zero. What's x going to equal when you do that?
Zero. Zero.
No, x minus 2 equals 0.
Oh, two.
Good. And we throw 2 back in.
Mm-hmm.
What does the whole thing become?
You throw two back in, so two minus -4.
Good.
Negative four. Yeah.
So you plot that point.
Mm-hmm.
And you know it's a V shape. So we
Yeah.
just plug in numbers close to 2. Like, what are numbers close to 2 that I could plug in?
Three, one.
Okay, that's it. That's all I need. So now what I want you to do is plug 1 in.
Mm-hmm.
What do you get when you plug 1 in? And be careful, please.
Mhm. -1.
Okay, what's absolute negative 1?
One.
And what's 1 minus 4?
Three.
No.
-3.
Sure. Now, if you think about it, if I plug 3 in, should I get
Mm.
the same Y value? Or should I get something different? Should I be like up here?
Probably different, yeah, a little higher.
You sure?
Well, lower, but like higher in
Well,
like.
think about the vertex as the axis of symmetry.
Yeah.
So if you were to predict what would be the Y value at x equals 3? Or
Um,
how's it compared to what the one I just found for x equals 1?
I think it'll be like two.
If I put in 3, I should get 2?
Oh, if you plug in three, one.
Okay.
Um,
And what's absolute 3 minus 2?
-1.
Slow down, dude.
That's the absolute value of one. One, I think one probably is the answer, but
Absolute 1 is 1.
yeah.
Okay. And what's 1 minus 4?
Three.
No.
-3. -3.
Okay. What do you notice about both these Y values?
They're negative.
And
Three. -3 both.
so both the same.
Yeah.
Okay, that's what I was hoping you would say. Why
Yeah.
should they be the same?
Because the thing's a straight line.
Well, kind of. It's symmetry.
Yeah, symmetry.
Okay. Like a V. Like,
Mm-hmm.
let's have a discussion about symmetry.
What?
Let's have a quick discussion about symmetry.
Yeah.
Okay. Okay, I wrote 4 letters down. Which of those letters has symmetry?
M
And
R. Oh
no.
no, no, A.
All right. Why is that?
Because it's the same on one side as on the other.
Good. Now, how about a V? Does that have symmetry?
Yeah, down the middle.
Okay. Aspect graphs have V's in them, right?
Mm-hmm.
So they have symmetry.
Yeah.
So if you plug 1 in, you get negative 3, plug 3 in. And why does that matter? Because if 2 is the vertex, right? X equals 2. Then if you pick numbers that are close to X of equal distance, must be close of equal distance, then they're going to have the same Y coordinates. So once you find one of them, if you pick another one that's of equal distance, it's going to have the same um, Y coordinate.
Mm-hmm.
And that's it. Then you have the graph.
Yeah.
Then you draw that.
Mhm.
Okay, let's try another one here. Okay, so set that equals 0. What makes that 0?
Um, -1.
Good. Okay. Now throw negative 1 back into the equation.
Mm-hmm.
What's Y going to equal?
Um, uh, y is an equal 0.
Good. That's your vertex.
Mhm.
Okay, let's plug in numbers close to -1. What numbers you could plug in?
-2 and 0. Is that all
Okay,
right?
good. Yeah, good. No, it's good. Yeah. Okay, if you plug in -2, what do you get?
Um, -3. Oh, no,
Mm-mm.
yeah, -3.
What's -2 plus 1?
1, -1.
That's why of that.
Uh-huh.
What's outside of that?
Wait, I'm sorry. Absolute value of
Sorry,
negative
sorry. I have food in my mouth. What's outside of -1?
1,
Good. So what do you expect if you plug 0 in?
1.
Good. That's how you do it. So these are the basic ones. So let's do a couple more here, and then we're gonna then jump
Mm-hmm.
to more advanced ones.
Mm-hmm.
Okay, set the inside equal to 0. What does x equal?
What?
Set the inside equal to 0. What does x equal?
Uh, 2.
Okay. Plug 2 back into the equation. What do you get?
0.
Take your time. Don't rush it.
Put 2, so 2 minus 2.
Just the whole thing. Just do the whole thing all at once.
Oh, 2 minus 2. Wait, hold on. Give up your cursor, please.
Sorry. No, you're right. 2 minus 2 is 0.
And then -2 is -2.
Good. And notice that this number is always going to be the y coordinate.
Yeah.
So good. Okay, now let's plug in 1.
Mm-hmm.
Plug 1 in. What do you get?
-3.
Good. Excellent. So I expect the same thing by plugging 3.
Yeah.
Good. Good, 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 good. There you go. Okay, awesome. All right. Here's what I like you to do. Can you write on the screen?
Yeah.
Try drawing number 8. Like try doing it on your own on paper, and
Mm-hmm.
then try drawing on the screen.
All right.
This will give you the confidence you need. Are you able to write on the screen?
Yeah, just give me a second. I'm still figuring it
Okay,
out.
okay.
Get some points real quick. Yeah, go around this. Just give me a second. Mhm. Two, three.
Good. Good. Awesome. You're putting the wrong graph. That's okay. I don't care.
Oh, Todd.
No, don't worry about it. It's all good. Good. So what you're noticing
Hmm.
is a trend.
Yeah.
And that's a general formula. I didn't want to start doing that way because I want you to think numerically what's going on. Now you do.
Hmm.
But yeah, H represents the x coordinate of the vertex, which in this case would be -1.
Uh-huh.
K, of course, is 4.
Hmm.
And then A, of course, is the leading coefficient. It's negative, so you go down one, right one, whatever. So okay.
Uh,
So now let's do more advanced ones. So 3x minus 3 equals 0. You want to solve for x.
hmm.
So if you do that,
Hmm.
you get 1.
Uh,
Then you throw 1 back into the equation,
hmm.
which of course the inside will be 0.
Hmm.
So still the outside number is a vertex. So 1, comma 1. We'll plug in 0 and 2, numbers close by. So it's not that much different, just just a little funky with the 3x in the inside.
Hmm.
If you plug in 0, that's going to be -3 times outside -3,
Hmm.
which I know is 3. -3 times 3 plus 1.
Hmm.
-9 plus 1 is -8.
Hmm.
So it's way down here.
Yeah.
The graph looks something kind of like that. Okay. Um, so it's not that much different. And if I plug in 2, um,
Hmm.
yeah, you get the same thing.
Hmm.
So go and try 7 now. What I want you to do is set the inside equal to 0. Figure out what x equals. Then throw
Well,
it back in.
yeah.
Yeah, keep going.
X would be zero then. Well, no, actually,
No,
it'll be
solve it.
negative. No, it'll be -4.
Take your time. Don't rush it.
All right, let me just do it real quick. 2 -2x plus 2 4. Right.
Yeah, 2x plus 2 equals 0. What does x equal?
Hold on. One second. Um, X equals 0 because
No, subtract 2, divide 2.
that was subtract. Yeah.
Right. You
Uh,
know this. 2x plus 2 equals 0. You've done this many
yeah.
times.
Yeah. All right. All right. Subtract it. Oh, so it's -1.
Okay, good. Now throw negative 1 back into the equation. What was y equal?
Oh. Oh. Ah. 2 times -1. -2 plus 2, 0.
Right. So then that's wiped away. And what are you stuck
Mm-hmm.
with?
Plus 4.
Good. So negative 1 comma 4.
Mm-hmm.
Then we'll plug in numbers close to negative 1.
Mm-hmm.
So negative 2 and 0. Maybe we'll start with 0.
Mm-hmm.
Plug 0 in, what happens?
If you plug 0 no what?
In the equation.
Um, plug 0. Well, then you're gonna get 0. So wouldn't that should be at 0, 0?
Yeah, you do. Yeah, because the whole thing becomes 0,
Yeah.
right? And then you get this.
Mm-hmm.
Okay. So let's try one more of these, and then I think we can move on to the next topic. It'll do 12 as our last one. So I want you to set this equal to 0, figure out x equals, then
Mm-hmm.
figure out what y equals, then make a table of values close, and I want you to graph it on the screen.
Um, I'll graph it. Okay, use the restroom real quick.
Take your time, you're good. Yeah, that's fine.
Mm.
Okay. Um, yeah, two for sure, three for sure. Going down, dude. Okay, you're good. Okay, I think you're set now at this. Good.
Mm-hmm.
I feel much better. So vertex line of symmetry is always going to be x equals, like in this case, that was -1, comma 2. So it's x equals -1. Y-intercept, just plug in 0 for x, see what happens. Then you get
Yeah.
-2. X-intercepts, kind of a pain in the ass. The
Mm-hmm.
range is easy. Like the one you just saw is y is less than or equal to 3. Here, y be greater than equal or less than equal to 2.
Mm-hmm.
To solve for the x-intercepts, you actually have to set the equation equal to zero
Yeah.
and go through the motions. So if we think about it, if I want to isolate x here,
Mm-hmm.
what's the first thing I need to move over?
But sorry, are you cut out?
If I need to isolate x, how
Oh,
do I do
two.
that?
Two.
Yeah, move the two over, so you subtract two from both sides. And
So it's just, yeah, minus two equals -2.
then divide by -2 after that.
Yeah. Mm-hmm.
So 1 equals absolute value of 2x plus 2.
Mm-hmm.
So then 2x plus 2 should equal 1, of course, or it could equal -1, because absolute -1 is still 1. So then you just solve in each case.
Mm-hmm.
-1/2, or here, -3/2. And those are your two answers.
Yeah.
So just, if that's asked. So, okay, that's good. I feel so much better now about that. Now let's talk about piecewise functions. Piecewise functions, you simply just don't gonna graph each one and then just choose a side to keep, depending on what inequality is next to it.
Mm-hmm.
That's really the best way to handle those kind of questions. So let me locate. There we go. We'll do nonlinear. Yeah, that I think that's fair. So
Mm-hmm.
you're graphing 2x plus 3 up 2 over 1.
Mm-hmm.
So that's easy.
Yeah.
However, it didn't ask to graph this for all of x, only when x is this.
Mm-hmm.
So you have to plug -1 back into the equation. You plug -1 back in,
Yeah.
what does that become?
If you plug -1 back in, it'll be
Mhm.
1 plus 3.
Yeah, yeah, it's 1. So it's right here.
Uh,
And you only want it when x is less than it, so you don't want any x values more than -1. So I'm going to do this. And
mm,
also draw a little hole there.
yeah.
It's not included. Okay. Then we already done absolute value. We know inside 0, plug in 0, you get -5. It's supposed to be a V shape. Plug in like 1, you get -4, or -1, you get -4. But you're only supposed to do this from -1 to 2.
Mm-hmm.
So they're both equal. Well, equals it right there. So I'm going to put a fill in circle and then put in 2 as -3.
Mm-hmm.
So you have that.
Yeah.
Then last here,
Mm-hmm.
you have y equals 1, which looks like that, but only when x is larger than 3. It's just right here,
Mm-hmm.
included. You do that.
Yeah.
So domain, obviously, there's nothing between 2 and 3.
Mm-hmm.
So we could say something like this here until we get to 2, or when
Mm-hmm.
x is larger and equal to 3. The range, obviously, it hits a high point of 1. It goes down forever, so y is less than or equal to 1.
Mm-hmm.
F of 1, put 1 back in to, over here, it looks like it's -4. Plus you throw into this equation because that's where 1 fits in right there. 6
Mm-hmm.
fits in over here, so that's 1.
Yeah.
0 also fits in over here, which is -5. So that's how you go about doing the piecewise. And these are obviously not linear. Um, let's look over here. That was a little too advanced, I think. No, that's gonna be too much for you. Yeah, that's fine. Close that line. Okay, we can try maybe one more. Um, so here's what I could do first. Go ahead and graph y equals negative x.
All right.
So figure out the slope and the y-intercept.
Mm-hmm. All right. Choose so
So when you have y equals negative x, you just plug in
Mm-hmm.
numbers
Uh, um.
plug in negative 4. What's negative 4?
Wait. Repeat what you said.
When you graph y equals negative x, just plug in the numbers you see. Like let's plug in negative 4. What's negative 4?
Positive 4.
Good. If I plug in negative 2, what do you get? What's negative 2?
Positive 2.
Right. And it's just a line. So you just have this. But
Mm,
negative 2 is not inclusive, it's just a hole.
yeah.
Now, let me draw a little better. Okay, so now the next one, put negative 2 back and you get negative 5.
Mm-hmm.
Hmm. So that's negative 5. Plug 1 to get negative 2.
Mm-hmm.
And so that's that. And then finally plug 1 in.
Mm-hmm.
That's negative 1. But it's a parabola. Like if I plug 2 and I get 2,
Mm-hmm.
plug 3 and I get 7. So it starts increasing pretty quickly.
Mm-hmm.
Let's get that. Now, domain, what's the lowest x value here?
Negative 2.
Right. No, no, no. Look at the graph. What's my lowest x value? Where does it start?
Oh, negative 4.
Right. Now, does it end to the right or does it keep going forever to the right?
It ends.
Really, where does it end for x?
Uh, Nowhere.
Nowhere. Yeah, exactly. So that's why x is larger than or equal to negative 4. Then the range, what's the lowest y value here?
What was Y value?
According to the graph, what's the lowest y value?
Um,
Just look at the graph.
I know, negative 5.
Right, correct. Then there's a gap between 2 and so you go, to 2. Negative 5 is included, 2 is not included.
Mm-hmm.
Or then you go from negative 1 up forever.
Yeah.
And look at the graph. If you plug in negative 4, what's the y value?
Um, Wait. If you plug in -4, what's the y value?
Yeah, according to the graph, when x is -4,
Oh, the y value is -4.
4, good. How about -2?
Wait, what?
How about -2?
-2,
Yeah, when x is -2, what's the y value?
2.
Well, there's a hole there,
Oh,
so it's got to be down at this place.
yeah. Negative. Oh, -5.
Right. And also look at the equation too. -2
Mm-hmm.
is not included here. It's included here, so you gotta go with this one.
Yeah.
Last, if you plug 1 in,
Yeah.
what's the y value when I plug 1 in?
Plug the y value of what?
Plug 1 in for x. What's the y value?
Um, with the y value would be 2.
Mm-mm.
Really?
Look at the graph. When x is 1, or throw 1 into here, right? What's the y
Negative
value?
-1.
Right. So that's what you have to do is you have to look at the graph or the equation itself and like pick the right condition,
Mm-hmm.
or based on the condition, pick the right equation that goes with it.
Yeah.
So that's how you graph the piecewise. These are I'm not too worried about. Like you've been fine with this, like just plugging in, working it out, and factoring. You've been fine for the most part too. So
Mm-hmm.
um,
Yeah.
sometimes they can get a little crazy. So let's just look at some crazy ones here. Um, so you take out x,
Mm-hmm.
you have this. So you have that.
Mm-hmm.
So um,
Mm-hmm.
so you a times c, figure out what adds up to 5. So you get a -3. Then you have to factor it. Probably best we just do the factor by grouping.
Yeah.
Mhm. So what can you take out of the first group?
The first group, you could take out x,
Hmm. 2x.
2x, actually. Oh yeah, 2x, yeah. And then second group, you can't really take anything out.
No, 1.
Yeah, -1, I guess so.
So you have 2x minus 1.
Mm-hmm.
So those are your factors.
Mm-hmm.
Nice Christmas colors here. And then see what makes each of these 0. So that'd be 0, 1/2,
Mm-hmm.
or -4/3.
Yeah.
Okay. Um, can I do the same thing here?
Mm-hmm.
32 and 3.
Mm-hmm.
To use a calculator if you need to, but then you have 12x squared.
Mm-hmm. Mm-hmm.
So you take out 4x.
Uh-huh.
If you can't think of that, put a 1.
Mm-hmm.
Then it'd be negative 1/4 and negative 8/3. Yeah.
Mhm.
Okay. Um, that's pretty straightforward there. For graphing,
Mhm.
remember to do negative b over 2a to find the x coordinate of the vertex.
Mhm.
So negative 4 over 2 times 2, that's negative 1. Throw it back into the equation. That's 2 times negative 1 squared, which of course is 2, plus 4 times negative 1, which of course is negative 4, minus
Mhm.
6, which is minus 6. That gets you negative 8. So that's your vertex. Once you do that, then you could plug in other points like 0, comma negative 6. You have symmetry. So it looks like that. Y-intercept's easy. We already got that. The mirror point, I guess you could say the symmetric point. So you could do like negative 2, negative 6.
Mhm.
X equals negative 1. X-intercept is factoring and solving, which I know you can do already. So not too worried about that.
Mhm.
X plus 3, X minus 1. So yeah, obviously I didn't do it accurately, but
Mhm.
range Y is greater than or equal to negative 6. Yeah, negative 3 and 1. So anyhow, and then lastly, this one here, end behavior, you always want to say as X approaches negative infinity,
Mhm.
what's Y doing? Or as
Going
X
away
approaches
from him.
positive infinity, what's Y doing? If it's going
Why?
down, you say
Yeah.
negative infinity up, you say positive infinity, both are going down. X-intercept,
Oh.
just look at it. Y-intercept, look at it. The relative max are
Mhm.
the peaks,
Mhm.
and you want to say them as coordinates
Yeah.
or just the Y values. Max is overall max or min overall min. Increasing is when it's rising, like it's rising from up to negative.
Mhm.
Can't read that. Negative 2.5 looks like.
Mhm.
And again, from like negative 1 to like 0.75, I think. So that's 1, probably 1.25. Yeah. And then decreasing in the other directions. Positive when you're above the x-axis.
Mhm.
So we're above from like negative 3 to negative 2, and from 0 to 2.
Mhm.
And then when you're below it, yeah, range, of course, is from, all the way up to 14, I think.
Mhm.
So you have that. Okay. Cool. Okay, we'll go stop there because I do have another call to hop on. So I'll
All
try to
right.
send this
Sounds good.
recording to you.
All
Yeah,
right.
and it looks like we're all done. I